All right, so here we go. Have a seat so people can see Daniel. Now is not the time to put your portfolio together since it was due at the beginning of class. Oh yeah, this camera doesn't work. I should probably fix that.
So just take pictures.
That's what I would do.
So I don't need this. I'm gonna just or this. So if I put it in my binder.
I swear to God, why are you asking me about this?
For organization. I'll just take pictures. I hope you're happy.
I hope you're happy.
I hope you're happy. I finished it 2 weeks ago. I hope you're not happy though.
Okay. Let's do this. So the first one. Here's what I did. I color-coded everything, and I didn't know this yet because it's not written down, so I had to find that. Is everybody cool with that? Awesome. Shut up. So I know that BD, which is this right here, is composed of two segments, BC and CD. So by segment addition postulate, BD equals BC plus CD. Are you with me? Those two together. Okay? What? BD equals BC plus CD. I wrote that. Segment addition postulate. I didn't know this was, I didn't know that yet. I wrote that later. Then I plugged in their values. I know that BC is 6, and I know that BD is negative x plus 1. That was by substitution. I didn't know CD yet. Then I did math and found out CD was negative x minus 5. So I wrote that up here. I did the same stuff for AC. AC is AB plus BC, so I wrote that down by segment addition postulate. Then I plugged in their values by doing substitution. And I found out AB was x plus 10, so I wrote that down. Then the logic is this. I know that AD is going to be AB plus BC plus CD altogether. So I wrote that down by segment addition postulate. Then I plugged in their values by substitution. I solved for x and it was 5. After that, I took x and plugged it in for AB. AB is x plus 10. So I wrote that because I found it earlier. And then I plugged in 5 by substitution and got AB is 15. Like they said it would be. How do you feel?
That's alright.
Yep, I did. Here, I'll zoom out. You can take a picture of it. Also, I have copies of this packet because I've done multiple versions of it. I did 3 yesterday. So here's a copy with almost all of it filled out. If you need it because I'm going too fast, it's right here. Okay? No, Danny took them all because he takes 2 at a time and then doesn't put them back when he's done.
I use 1. People use 2 at a time.
Do you ever put them back when you're done? No, you don't. Times are tough. Yes, you may go to the bathroom. It's not in here. Blackhawks were up 3-0 going into the third, and the Blues came back and won 4-3 the other night. So feeling pretty good. What?
You want this stapled if I'm putting it in a binder?
No?
This is due today. Yeah, 3 to plan ahead. 2, 1.
All right, next. Deriving distance formula from the Pythagorean theorem. So here's the idea. I drew a coordinate plane, and look. This coordinate would be x1, y1, because it's the first x and the first y. This is x2 and y1, because it's the second x over here and the first y. Does everybody see how that's x2, y1? Okay. Then, this would be x1, y2. A and B are the vertical and horizontal distance. The vertical distance will be however long this is. Well, how long is it? Well, it's whatever these numbers are subtracted from each other. Like if that was 10 and that was 2, well, the length here would be 8, right? So algebraically speaking, it's y2 minus y1, whatever it is, right? Same thing for B. If that was 10 and that was 2, the length would be 8 here, because you'd subtract them, right? So B's length is going to be x2 minus x1. What do these stand for? Well, subtraction is distance, y is vertical, so vertical distance. Subtraction is distance, x is horizontal, so horizontal distance. That's what that stands for. So we find the horizontal distance and the vertical distance between these 2 points. We put them into Pythag, and we're able to find the distance between them. Again, there's a horizontal component and a vertical component to this distance, right? So instead of trying to do them both at once and calculate how long that is, we break them up, put them into Pythag, and find the hypotenuse. So I'm going to take those things right there, and I'm going to plug them into Pythag, which is a squared plus b squared equals c squared. A is this, b is that. Yes, a is y2 minus y1 in this diagram. Don't goof it up. It's not the x's in this one. A is the vertical part. B was the horizontal part. I square them, add them, and root them. Derive the distance. Don't you have the packet? Open up to page 4. Questions on 4? It's a lot of stuff, but if you know what it means, it's not complex. Label your points, find the distances, plug them into Pythag. Yes. They're from Casey's. Help yourself. You can thank Evan's mom, Janet. Shout out to Janet. Evan, that's your mom. Why would you say that about her? She'll watch this stream later. Janet, he doesn't really feel that way. He's just going through a phase. All right. Next up. So, 2 things here. It says distance formula between the 2 points and find the midpoint. How do I know it's midpoint? Because it's a 1-to-1 ratio. 1-to-1 ratio means the same on each side. So if it's the same length on each side, the point in the middle would be the midpoint, right? If it was 2-to-2, it would also be the middle. 3-to-3 would be in the middle, right? It's the same on each side. So here's x1, y1 because we're starting here, and then we're going there. That's x2, y2. The formula for midpoint is average of the x's, average of the y's. When we average stuff, we add and divide by the number of pieces. We have 2 pieces, 1 on each side. We start with x2 and y2 first because direction matters. Starting on A and going to B is different than starting on B and going to A. Not for this problem, but for other problems. What's your question? Distance?
The distance of that line?
Yes. Which we just proved in the last page. Very good. So, when we plug in those points, we add them up and divide by 2 for midpoint, and we get 3, -2. And if you look, it is between A and B halfway. To find the distance, you can either do distance formula and plug in your stuff to that formula. But think about what it means. This right here is calculating horizontal distance. 4, right? That's how far they are apart horizontally. You don't need to do math to figure that out. You have this to count, right? You could do math and figure out how far apart -7 is from 3. Well, it's 10 apart. 10. So plug it into Pythag. This first step of distance formula just calculates those distances, but you could count them, so why calculate it? Same dumb thing. You get root 116 either way. How you feeling? Yes, I can. I'm going to zoom out now. Boop. You're welcome. Today's stream is once again brought to you by Clausen's Pickles, the crunch that keeps on giving. When I eat pickles, I always choose Clausen. Ready for page 6? Check it out. Page 6 is the same dumb crap, except it's 3-to-5 for the ratio. Why is it 3-to-5? Well, the fraction is 3/8, meaning we want to find 3/8 of the way between the 2 points. Well, 3/8 of the way is 3 out of 8. So we have 3 versus 5 here going on. 3 versus 5 going on. So our ratio is 3-to-5. Again, the top number goes here, and then what's left over goes next to it. It's 3 versus 5. Not funny. 3 versus 5. On the last page, our ratio is 1-to-1. And you didn't see it, but there are actually 1s next to those x's and 1s next to those y's. There are, we just don't write them because y right times 1. But here, we're going to put the 3 and the 5 next to the x's, in that order, x2, then x1. Then a 3 and a 5 next to the y's, y2, y1. And we're dividing by 8, because 8's the total amount, right? When we average, we take the total number and divide, right? If you were to plug in your points, you get -32 and -8. Both of those divide by 8 evenly. We get -4 and -1, which means that coordinate, -4 and -1, is 3/8 of the way going from A to B. If you had mixed up your x1 and x2 and your y1 and y2, if you flipped them, you would have gotten the point that was traveling from B to A, so you would have gotten that one, which is 3/8 of the way, right? So make sure you do x2 and y2. Next. Don't throw the cookies. It'll make a mess, and then people that are very nice will have to clean it up, because you won't, let's be honest. This one wants you to find the point that's 2/7 of the way between A and B. So the ratio is 2-to-5. Does everybody see how that ratio is? Where I got that ratio from? 2/7 is a 2-to-5 ratio because it's 2 on one side, 5 on the other to make up 7 total. Nope. I just didn't want to do the whole thing. That's going to be 2 and 5 next to x2 and x1 in that order. 7 total. Same thing for your y. Do your stuff. Do Pythag/distance formula to find the distance. Midpoint. Brace yourself. It looks gross. Here's the idea. Okay? We have the endpoint given to us, a midpoint given to us, but we're trying to find the other endpoint. Normally, it gives us the 2 endpoints, and we plug it in, and it gets us the midpoint, right? That's normally what midpoint formula does. We plug in our endpoints here, and we get the midpoint. But we already know the midpoint, so I plug that in. I already know one of the endpoints, so I plug that in. I don't know the other endpoint, the x2 and y2. So I'm going to solve for those. So here's what I have to do. I have to get x2 on its own. So what do? I times 2 to this side, and then add 3. I get 5. On this side, I times 2. What's 5 halves times 2? Well, it's 2 divided by 2, which is 1, times 5, which is 5. Then I add 2, and I get 7. So endpoint number 2 is at 5, 7. Here's some logic for you. The endpoint is at -3 in the x part, right? And then it goes to 1 halfway there. How much did I add to get from -3 to 1? 4. I added 4 to get from -3 to 1. So halfway took adding 4 to the x. So if I add 4 more, I should get the other endpoint, and I do. If I'm at -2 and going to 5 halves, that's 2.5, so I added 4.5 to get there. If I add 4.5 to 2.5, I get 7. So you can check your work with that. Do you need to show this work? Oh, absolutely. But the idea plays out, yeah.
So are you gonna make us do like those writing ones where we have to like on the last quiz, we had to prove to you why?
It's in the review packet. How about you read the review packet instead of wasting everybody else's time to review? Thank you. Name the angle MAP, PAM. Remember, A has to go in the middle because it's the vertex. We can also call it angle 5. We can also just call it angle A by its vertex. I don't prefer that last one because if there was another ray coming off of here, then we wouldn't know which one was angle A, right? It could be the top, could be the bottom, could be the whole thing, right? But those are the 4 possible names. The 2 rays are ray AM, again, going in the direction of M, and ray AP, going in the direction of P, so A to P. Definitions. Here they are. So, acute. If it's between 0 and 90, it's acute. No lines underneath here because if it equaled 90, then it would be a right angle, right? So it doesn't include 90, doesn't include 0. 0 to 90 doesn't include 90, doesn't include 0. Right angle is 90. If it's between 90 and 80, not including 90 and 80, it's obtuse. Again, the idea is like pick a number between 1 and 10. You're not allowed to pick 1. You're not allowed to pick 10. What is an obtuse angle? It's a number between 90 and 180 degrees. You're not allowed to choose 90. You're not allowed to choose 180. All right? Because if it was 180, it'd be a straight angle. If it was 90, it'd be a right angle. 180 is a straight angle. Reflex is between 180 and 360. That's a lot of territory there. Reflex angle is anything that's hyperextension, right? Revolution, 360. A revolution, right? Bernie Sanders. Then we have A and B added together. If we have 2 angles added together and they add up to 90, we call it complementary. If they add up to 180, we call it supplementary. Yes.
Can we write that in quiz, like, or the test?
What?
Angle A, like in words.
Did I write this?
Angle A plus angle B equals 360.
If that's the case, then they're complementary, yes.
Can you write that in words, though?
If angle A is an angle that adds with another angle to equal 90, then it's complementary with that angle. Yes. Yes. I don't care how you write it. This is the most efficient way to do it, because otherwise you have to write something like any angle that's between 0 and 90 but doesn't include 0 and 90 is acute, right? I'd rather write it like this. It's between 0 and 90, doesn't include them. Oh God, don't look at this one. Page 11, right? I have it memorized, yep. This one doesn't have it. This one does. 11. Cross out where it says BAF is 165 and write 135. Cross out this arc and make that the arc. Sorry. I just shaded the wrong things. I know. All right, so here's how you solve this one. First of all, write the given. This guy is 95. That's what they gave you. This angle, and this angle all add up to this angle, CAF. So I wrote that by angle addition postulate. Then I substitute their values. 35 plus 2x plus 40 should give me the whole thing. And I know the whole thing is 95, so I put that in. That's by substitution. Then I solved and got x is 10. Then I said that this angle, this angle, this angle, and this angle all add up to the big angle, BAF. So I wrote that by angle addition postulate. Then I plugged in their values. 4x plus 35 plus 2x plus 40 equals BAF, which I don't know yet. That was substitution. And then I plugged in x. It was 10. I did that by subs. And I got their values, 40, 35, 20, and 40. When I added all those up, I got 135, which is what we were supposed to prove BAF to be. Do you need to write this stuff over here by substitution, by angle addition postulate? Oh, yeah, that's the point. Yeah.
No, but do we have to write, like, all the stuff you did in the middle of that?
Like what? This?
4x plus 35 degrees plus 2a plus 40.
Yeah, that's by substitution. We started here, and then we substituted their values. Then we got their values times x, and then we had these. Yep, I'm zooming out now. Take a picture quickly. If you don't end up getting a picture because I go too quickly, just ask for the packet after class. I can give it to you. Not to keep. Next page. Oh, God. It's a stir. Look at it. He's waving high. It's a concave polygon because it pushes into itself. Another way to tell, and really the real way to tell, there's two ways. One, look at the internal angles. We have an angle here, an angle there, an angle there, an angle there. If there's at least one, all it takes is one, angle that is greater than 180 on the inside, then it's concave. See how this is way bigger than 180 degrees? Right? That's almost 360. That means it's concave. All you need is one. This one has 5. Very concave. It's a decagon because it has 10 sides. And, of course, everybody knows December is the 10th month of the year. It's the 12th month. It used to be the 10th. The Romans were in charge. They had it make sense. October was the 8th. September was the 7th. It all made sense. And then we screwed things up by making January the first month of the year. You guys know why we call it July? Julius Caesar. Do you know why we call it August? Augustus Caesar. Right? Yep. Anyone know why we call it February? Neither do I. Next one. All right, so then we need to find the perimeter. So we need to find the length of all these segments. How do we find the length of BC? How do you find the length of BC? You count it. You count it. It's 8 squares long. How do you find the length of JK? You don't count it because it's at an angle. You make a triangle, a right triangle, and you notice it's 4 by 3. So 4 squared is 16, 3 squared is 9. Add them together, you get 25. Root it, the distance is 5. Notice that it's also 5 here because it's 4 by 3. Notice that it's also 5. Nowhere else we only had 2 5s. Nope, here it is, 4 by 3. There's another 5. This one's 2 by 4, so it's 4 when we square it, and it's 16 when we square it. We add them together, we get 20. We root it, we get root 20. Same thing here, twinsies. 2 by 7 here, so it's 4 and 49. We add those together, we get 53. That's root 53. Same thing here, same thing here. Root 34 is all alone. 5 by 3. It's 25 plus 9, which is 34. We root it, it just stays like that. So then we add them all up. I had 5, 5, 8, and 5. That adds up to 23. I had 2 root 20, so I wrote 2 root 20. I had 3 root 53, so I wrote 3 root 53. And root 34 was all alone, so just root 34. Could you plug this in a calculator and get a number for it? Sure you could. But ain't nobody got time for that. Also, it's a decimal that goes on forever, and no one wants to round. Because if you round, it means your answer is less correct than mine. Because you had to estimate. So why do that? Hello. Good, I'll wait. Next one. Concave or convex? Concave because we have at least one angle on the inside is greater than 180. We have 2. Concave, it goes into itself. How many sides? 1, 2, 3, 4, 5, 6, 7, 8. So we call it a what? What do we call this? 8 sides. Octagon. Very good. This is the thing those people fight in UFC. Should probably run over here and hide. That's what I would do in this corner. Can you imagine, right? UFC fight starts and they're in this shape and they're like, oh my God, what is this? And they're like, they told me to build an octagon. Right? That's right. Conor McGregor running around this ring, right? Loser. All right, so next one. Concave or convex? Concave because it has 1, and all it takes is 1, internal angle that's greater than 180. It's concave. It caves in right here. How How many sides? 1, 2, 3, 4, 5, 6. So it's a what? Hexagon. Very good. Of course. Next one. Oh, God. Concave or convex? Concave, because it has 2 angles that are greater than 180. All it takes is 1. And it's 12 sides, so we call it a dodecagon. Do meaning 2, dec meaning 10, because December is the 10th month of the year. Dodec is 12. Dodecember is what we call it, obviously. Here's an example of a convex shape, because all of those were concave. This is convex because all the angles on the inside are less than 180. Also, a fun way to be able to tell real quickly, if you extend the lines of the shape and none of them go inside the shape, then it's convex. If they extend inward, like if I extended this, it would extend and cut through the shape, then it's concave. It's another way to think of it. Again, 12 sides. You better hope I don't give you a 12-sided figure. That's a lot to calculate for the perimeter. But some of them are bad, right? That's 2, that's 2, that's 3, that's 4, right? You get some easy ones. Questions on those ones? Knock them out of the park. Next, easy proof time. Check it out. It says, given that negative 3x minus 7 equals 14, prove that x equals negative 7. Okay, cool. So what am I going to do? I'm going to add 7 by the addition property. Right? Then I'm going to divide by negative 3 by the division property. And then I'm going to get x is negative 7. I'm going to call it a day. Smell what I'm stepping in? Number 20, for fun. What 2 properties would I use to solve it? Zayden's seen this 4 times already. 3 times. He was here yesterday. It's the same bit every time, isn't it? Zayden, no answer. What properties are we going to use to solve this? What properties are we going to use to solve it? Cheyenne. Very good. We're going to use addition to move over the 3. And we're going to use multiplication to get rid of the divide by 2. And we're going to call it a day. Guess what? X will be negative 32. 21. Given A, B, and C are collinear. I swear to God, what does collinear mean? On the same line. Do not write A, C, B in that order because you want to be creative. It's A, B, C collinear, so you write it in that order. Then you plug the stuff in, right? The whole thing's 6, it says. We're going to prove BC is 2. So first step I do is I write down by segment addition postulate. Danny. By segment addition postulate, we add these 2 up and they equal AC. Then I do substitution and plug in their values. Then I solve for X. It'll be some number, and then I plug that back in for BC, and I'll find that BC is 2. Remember, when you plug stuff in, it's substitution. Okay? How do you feel about that one? Are you with me still? Okay. No, tomorrow we are reviewing our portfolios.
So what are we doing, like,
You'll be reviewing on your own. Watch the review session if you want, or team up. Why am I answering this now? We have a limited amount of time. Do you understand my concept here? We only have so much time in class to review for these people that may or may not be able to show up to the exam, so I should probably utilize that time as best as possible for them. So questions that can wait to the end should wait to the end. Write it down? I don't know. Sounds like a you problem. ABC is an angle. D is in the interior, so I put it in the inside. ABC, they said, is 165. ABD, they said, was x over 3 plus 45. They said CBD was 3x plus 20. So here's what I would do to prove this. I would say by angle addition postulate, ABD plus DBC gets me ABC. Then I'd use substitution and plug in their stuff. Then I would solve for x. I would get 30. Then I'd plug in 30 for this. ABD equals x over 3 plus 45. By substitution, it equals 30 over 3 plus 45, which means this is going to equal 55. Swag boxin'. Why are you writing this? Wait, it's not even complete. I didn't do the whole thing. It's just a drawing. You've given up on the... Okay.
No, I'm getting another one. I'm going to do my own.
Oh, good idea. I thought that was your portfolio. 25. The only thing funnier than 24. This is the one that everybody got confused on.
That's confusing.
All right, so here's the idea. Let me break it down for you. They give us that JK and LM are the same, so I did them in the same color. That's probably smart. Check it out. JK and LM. They're the same. Then it says something about JL and KM together, so I labeled those with red and orange. The red part is this, JL. And the orange part is this, KM. Now, we don't know anything about JL and KM. They didn't give us anything, so I have to get it from the diagram. Notice that JL is JK plus KL, so I wrote that down. Also notice that KM is KL plus LM. So I wrote that down. Because JK and LM are the same thing, I rewrote JL as JL equals LM plus KM. See how I switched JK for LM here? And I can because they gave me that. Now notice that KM and JL equal the exact same thing. Well, if that equals that and that equals that, shouldn't they equal each other? So I wrote that by substitution. I took this and I plugged it in up here because it is that, right? And then I flipped them using symmetry property. That way they'd be red first, orange second. Proof done. Do you need to use symmetry all the time? No, you could have written it correctly the first time. But I didn't, so I could show you that that's how you flip them. Symmetry property. How do you feel? Decent? You've already seen this multiple times. Nancy? Okay. Bare hands. You here? Don't lie to me.
Nope, he's not.
Interesting. You're watching the live stream?
No, I took a picture.
Got it.
You're just weird, Carter.
That's weird.
He's a weird guy.
Yeah, he's a weird guy. What a weird guy. All right, so 26. Another confusing one. This is a bunch of garbage, right? But if you write it down, it's not so bad. Write the given. 1, because it's 3 points. 2, because when you write it, the answer kind of pops out. So just focus over here. They want us to get blue and orange together. So here's blue and orange. Here's what I would do. Orange is green, and green's the same thing as purple. So I'm going to write orange is purple. Then I'm going to notice purple's the same thing as blue, so I'm going to write orange is blue. Okay? Here's the idea. Orange is purple. How do I know that? Because green and purple are interchangeable. That's substitution. Purple is blue, so I'm going to switch purple out for blue by substitution. Look, that's what I wanted. Orange and blue in the same thing. But I wanted blue first. So I flipped them using symmetry. How you feel? Are you okay? I know this is super fast to get through this, and we're still not going to get through the whole thing, which is why I encourage you to watch review number 1 from the other day. The first hour is really boring, but the last 2 hours are pretty funny. Also, it really goes through slowly, and that's how I came up with all this stuff. I wrote it during that time. We only have so much time today, unfortunately. But if you have questions, ask now. We can take time to do that.
I would stay, but we have practice.
Great, fantastic. No one cares. Do or do not. No one cares about why. All right. 28. So I wrote down all the stuff and gave it colors, and I wrote down my given. Do that because, 1, you have to, and it's free points because you literally just write down what the instructions say. And then 2, it kind of helps you with the setup. They say 1 and 2 are supplementary. They say 3 and 4 are supplementary, and they say 2 and 3 are the same thing. So I'm going to write what 1 and 2 being supplementary means. It means that they add up to 180 by the definition of supplementary. Same thing with 3 and 4. They add up to 180, right? That's what that means. Then because this equals 180 and that equals 180, they should equal each other. So I write that by substitution. Then because 2 and 3 are the same thing, I switch out 3 for 2. So I can subtract them and make them go away. I do that by the subtraction property. I get 1 equals 4, which is what we wanted. Then I write it like this, and I'm done. They wanted us to show that 1 was 4, and I did it. How do you feel? Dees? Evan, you with us? Okay.
So you said there's going to be about 20 questions? You're making fun of one of your kindergarten kids. The one that didn't have the thumbs.
$30. Define all the stuff. I didn't write it down, so listen up. Transversal. It's a line that cuts 2 other lines. Do those lines have to be parallel? No, they don't. It's any 2 lines. When they're parallel, magic happens, though, right? Corresponding angles are any 2 angles that are in the same relative spot. So like 1 and 5 are the same relative spot. They're both in the top left corner of their intersections. When the lines are parallel, corresponding angles will be congruent. Same side interior angles are the angles that are on the same side of the transversal, like 1, 2, 5, and 6. And they're in the interior, so 2 and 5. Alternate exterior angles. They're angles that are on the exterior, like 1, 4, 6, and 7. Alternate means they're on opposite sides of the transversal, so 1 and 7 and 6 and 4 are examples. Now you might say, wait a minute, 1 and 4 are on the same side, and they're on opposite sides, and they're on the exterior. So why aren't they alternate exterior? Because 1 and 4 can better be described by a linear pair. 1 and 7 are better examples of alternate exterior angles. That's why we exclude 1 and 4, because they're more accurately described as a linear pair. So 1 and 7 are alternate exterior angles. 1 and 4 are not. Okay? You also need to know about same side exterior. That means angles on the outside, exterior, and on the same side. So 1 and 6 are on the same side and the exterior. Alternate interior, you also need to know about that. It means they're on opposite sides of the transversal, and they're in the interior. So here's the interior. On opposite sides are 2 and 8 and 3 and 5. And you might say, well, 5 and 8 are on opposite sides and in the interior, but they are better described as a linear pair. So we call 2 and 8 and 3 and 5 alternate interior, not 5 and 8, not 2 and 3. Got it?
Yeah.
31, we're on page 22. Prove that angle 2 is congruent to angle 7. So here's what I did. You could do it differently, but here's what I did. I said 2 and 3 are the same by vertical angles, and 3 and 7 are the same by corresponding. And by substitution, 2 is 7.
LPT.
Again, write your givens. L and M are parallel, otherwise none of this works. 4 and 3, I want to prove 4 and 7 supplementary. So I look at 4 and 3, because they're kind of similar to 8 and 7, right? 4 and 3 are supplementary by linear pair. And then 3 and 7 are the same by cap, so I can switch them out by substitution. Therefore, 4 and 7 are a linear pair. So these are a linear pair. 3 and 7 are the same, so I switch out 7 for 3. And now 4 and 7 are a linear pair, which means they're supplementary. Got your pictures? How do you feel about these two proofs?
I think those are easy.
They can be if you know what you're doing.
Proofs are pretty easy.
If you don't, you're going to be in trouble, right? Make sure you're not BSing this, Evan, right?
Yeah, even this is 2 weeks in a row.
Make sure you actually know what you're talking about. Don't try to jerry-rig your way through it.
Who made you that horse?
This one, they give you a bunch of angles. These two are 50, and this is 145. The first question they ask is about the red angle and the blue angle here. What are they? What kind of angles are these? These two. Vertical angles, very good, and that means that they're the same, so they're both 50. Could you figure out the rest of this diagram and what they are? You've seen this before a couple times now. How do you feel? No? You suck at this? So, notice that this angle right here from A to D is vertical with this one. So whatever this whole thing is, that'll be the same here. That's a big key. Another thing is that this whole thing's 145. I know this is 50, right? Because this is by vertical, right? And then I know this angle right here is whatever's left over, because that's 50-50, so this must be 45. Okay? This right here is a linear pair, so 50 in this guy. So this must be 130. And if that's 130, then this is 130 by vertical. 50 and 45 makes 95. What's left over is 45, so this angle right here is also 45. Wait, did I do that wrong? Yeah, I did. It's not 45, it's 35. 45 and 35 makes 80, plus 50 is 130. This whole thing is vertical to this. And that gets you all your angles. Feel better? Good. Think creatively. Raise your hand if you get stuck. It's hard seeing it, right? Seeing it is the hard part. Next one. All the lines are parallel, so I write that. Given P and Q are parallel, and M and N are parallel, I'm going to try and prove 3 is 15. So here's what I'm going to do. 3 and 7 are the same by cap. 7 and 15 are the same by cap. That means 3 and 15 are the same by subs. Then it wants to prove that angle 10 is supplementary to angle 7. So here's angle 10. Here's angle 7. I'm going to say 10 and 11 are supplementary by LPT. 11 is the same as 15 by cap. 15 and 7 are the same by cap. So I switch out 7 for 11 by subs. And so now 10 and 7 are supplementary.
What does cap stand for?
Corresponding angles postulate. Corresponding angles, right? Same location, top or bottom right, bottom right. It only works when the lines are parallel. Notice that we have two parallel lines here cut by a transversal, which means 11 and 15 will be the same, right? Here, we have two parallel lines cut by a transversal, which means 15 and 7 will be the same. So cap works, right? If they weren't parallel, like this one, they wouldn't. Do we have two parallels cut by a transversal? No, we do not. So 10 and 14 aren't the same. But 10 and 2 are two parallels cut by a transversal. 6 and 14 also would be, because two parallels cut by a transversal. Would 2 and 6 be congruent? No, because they're not parallel, right? So 2 and 10, 6 and 14 are the same. They give you a bunch of numbers to plug in. You're going to figure out what all these things are. So they say angle 7 is 85. That's this angle down here. And they tell you that angle 10 is 115. So that angle right there is 115. So that means we get angle 2 by cap. We get angle 11 by linear pair, right? We get angle 6 by linear pair. It's going to be 95, right? Adds up to 180. And if that's 95, that's 95 by cap, right? So you can kind of figure out all the rest. Vertical angles gets you this one, right? Angle 5 is 85, so on and so forth. That one's not so bad if you know what you're doing. How do you feel about this one? Grand. Buckle up. Prove angle 6 is 160. Don't take a picture to the end. Just watch. You're going to need to see the whole thing, okay? Here's the idea. I know angle 1 and angle 5 are the same by cap. I know 5 and 13 are the same by cap. So by substitution, angle 13 must be 2y plus 8. I know 13 and 14 are supplementary by linear pair, which means 2y plus 8 plus 30y minus 20 should add up to 180. I do math and solve for y. It's 6. Then I plug that in, and I get that angle 14 is going to be 160. By cap, 6 is 160.
Where did class time go? That's insane. That was like the shortest class we ever had in class.
I know, it's because we spent the first 20 minutes goofing around. Turn it in the bin.
Hey, can I borrow some tape?
No.
Or use some tape?
Yeah, you won't be.
Yeah. Why would you?
If you want to see more of this, watch it online and or come in tonight from 6 to 9. That's the last geometry review session. If you'd rather take the packet,
I would be working on my portfolio.
I have a packet up here that you can look at. Uh-oh, why did my thing freeze?